Chapter 2 is all about linear equations in two variables. In Chapter 1, we were working in one variable, so we were graphing on the number line. Now that we're working in 2, we're going to learn to graph on the overlap of two overlines, which is other number lines, which is otherwise known as the coordinate plane or the xy plane. So let's do a brief introduction to that. So section 2.1 to 2.2 is about linear equations in two variables and their slope. So this is the coordinate plane. The major parts that we have are the x-axis, the y-axis, and the origin, which is the very center 0, 0. It is broken down into 4 quadrants, which are numbered counterclockwise. I know that's a little intuitive, but we've got quadrant 1, 2, 3, and 4. The points on the x-axis and y-axis do not belong to any quadrant. Aside from being called the xy plane, this is also called the Cartesian plane or rectangular coordinate system. So in order to plot any point on the line, it is any point on the coordinate plane is going to have its own unique x value and y value. So for example, if I was to plot this point here, this is when x, because this is my x-axis, is 4, and this is where y is 3. In quadrant 1, x is positive and y is positive. In quadrant 2, x is negative and y is positive. In quadrant 3, both x and y are negative. And in quadrant 4, x is positive but y is negative. And what I do when I plot a point is I represent it with this ordered pair. An ordered pair always has x first and then the y. And it's easy to remember because it's alphabetical. So an ordered pair of numbers enclosed in parentheses and separated by commas, such as the point 2, 1, is called an ordered pair. Our first number is our x coordinate, and our second number is our y coordinate. So like I said earlier, it's alphabetical. The order is important, also the fact you get parentheses around it, so it tells me that it's an ordered pair. So let's look at the following ordered pairs. So if I wanted to find A, that's when x is negative 6 and y is 5. B, that's when x is 1 and y is 3. C, it's not in any quadrant because it's on the number line, but this is when x is 6, but my y value is 0. Remember, our origin is 0, 0. And D, well, that's when x is negative 1 and y is negative 5. So points, if a point is located on the x and an axis, one of its coordinates is always 0. So any point on the x-axis has a y coordinate of 0, and any point on the y-axis has an x coordinate of 0. I don't know why PowerPoint chose to give me a skeleton and an oil barrel. Good job, Microsoft. So now would be a good time to define what a linear equation in two variables is. So any equation can be written in standard form, which is ax plus by equals c, where a, b, and c are any real number, and a and b are both not 0, because if they both were 0, we'd just have a constant. This is a linear equation in two variables. And the graph of any linear equation is a straight line. And all of the points on the line that we draw, just like before when we drew on the number line, every single one of those points was part of the solution. Now, all the points on the line are going to be the solutions of our equation. So let's practice finding a few points that are solutions. Now, because we're graphing a line, right, there are infinitely many points on a line, right? If I have a line, there are all these points on the line. There are infinitely many solutions. But let's go ahead and find a few. So let's fill in the table given the x and y values. So I have the linear equation 2x plus 3y equals 6. So here's when x is 1. Let's go ahead and solve. So I have 2, substituting in for x, times -1 plus 3y equals 6. That means -2 plus 3y is 6. I add 2 to both sides. 3y equals 8. Y equals 8/3. Again, we're solving for our unknown variable. So when x is -1, y is 8/3. That's the point on the graph of this line. What about when x is 0? So if I have 2 times 0 plus 3y equals 6, I'm going to divide both sides by 3 because this cancels, and I get y equals 2. So when x is 0, y is 2. And that point is on an axis, right, because one of the values is 0. This is actually the point on the y-axis. Last but not least, instead of substituting for x, let's substitute for y. Substituting for x typically is the norm, but we can substitute for y. If I have 2x plus 3 times 5 is 6. 2x plus 15 is 6. Subtract 15. I get 2x equals, oh gosh, -9. So x equals -9 halves. So when x is -9 halves, y is 5. So each one of these ordered pairs is a solution because it's said to satisfy the equation, meaning if I substituted it in, I would get a true statement. So if I graph a line, there are two really important points we want to be able to recognize. The first is the x-intercept. So if the x-intercept of a straight line is where my graph crosses the x-axis, and it's going to have the form when x is some number, so let's pretend this is like -3, y is 0. The y-intercept is where my graph crosses the y-axis. So this would be, let's say, when x is positive, when x is 0, because it's a y-intercept, my x value is 0, and y is 3. It's always going to have the form 0, comma, a constant. So why don't we solve for the x-intercept and y-intercept, and then we'll graph this line. So in order to solve for the x-intercept, you always let y equal 0, and to find the y-intercept, you let x equal 0. So let's find the x-intercept and let y equal 0. That means 4x minus y is 3. 4x minus 0 is 3. 4x is 3, so x is 3/4. So I have when x is 3/4, y is 0. This is a point on our line. So when x is 3/4, y is 0. Now let's find our y-intercept. That means I substitute in x equals 0. 4 times 0 minus y is 3. Negative y is 3. Y equals -3 because I had to divide both sides by -1. So y equals -3 when x is 0. Now, I'm going to go ahead and draw my line between these as best as I can. Okay, cool. So here's a graph of our line. Note, in order to graph a line, you need to find 2 points. Let me show you why. So let's just say I found 1 point on my line. Well, the thing is, I could draw infinitely many lines through that 1 point. I don't have any set direction. But if I have 2 points, there's only one possible straight line I could draw between those two. And 2 points that are great to find when graphing a line would be your x and y intercepts.